Okay, we've had some questions concerning reducing radicals, rationalization, and all the different various operations that you can do with square roots and cube roots. So let's just kind of look at some examples, see if it can help you out some here. First thing you need to know is basically standard format for radicals. And when we say radicals, we're talking about your roots. So we're talking about square root of a number or cube root of a number. Now you can have any other root. The root is this shape right here. This is called a radical. Okay, so the little check mark looking thing, that is a radical. The root is based on what number, I'm going to put an in there, whatever number is there tells you what root you have. So if they write a number, that's your root. So if you see a little 3 up there, that's your cube root. If you see a 4 there, that's the 4th root, and you know, you can go on from there. Normally you don't see the larger ones. Normally it's nothing there, like here, and if they don't write anything, that is your square root. It's kind of like we do it so much, it's an understood 2 there. Now what they're getting at is when you do a square root, basically you have to, well, it's kind of hard for me to explain here. Shouldn't be. If I do the square root of 25, that's saying that, here, let me take this out of the way. If 25 is made up of 5 times 5. Well, do you see that there are 2 factors of 5? Okay, the 2 factors matches this 2 out here. So that's how many factors you must have under the radical to get one of the factors outside the radical. So since I now have 2 5s underneath, I get 1 5 outside. So the square root of 25 is 5. Okay, now if you don't meet the requirements, like if I did the cube root of 4, well, if you broke that down, and I kind of got a mess here, let me take this out. That would be, oh, 4 is just 2 times 2. I have 2 2's. Well, I need 3 2's. So I don't meet the requirement. So you're stuck. That means that you are stuck with the cube root of 4 is just cube root of 4. You cannot reduce that anymore. And in math, it's kind of like math etiquette. You're supposed to reduce that thing as much as you can. It's kind of an understood reduce it, just like reducing fractions. Now, to help you reduce radicals, it is really important to be familiar with your perfect squares and your perfect cubes. Now, if you do not have these memorized already, then you can make your own list anytime you want to, so nobody needs to freak out. All you have to do is come over here, and when it says perfect squares, you make your little list. 1, 2, 3, 4, 5, 6, 7, just keep on going, and then come back through and square every one of these numbers, and of course you can keep on going, go as far as you need. But then square the numbers. 1 times 1 is 1, 2 times 2 is 4, and this is 9, 16, 25, 36, 49, and so on and so forth. But these numbers over here on the right, those are the magic numbers. Because those are the ones that when you get them underneath this square root, it works perfectly. It's beautiful because like the square root of 4, that is 2 times 2. So you automatically get a 2. So these numbers are the ones you want. So the more familiar you are with these numbers, the easier these problems will be. Now, if you're working with cubes, you need to be familiar with the perfect cubes. So come through here. Most people don't do a whole lot of these because they get really big really fast. So if you can go through 5, that kind of gets you the basic idea. So 1, but you got to do all 3, and remember you're multiplying. 1 times 1 times 1 is 1. When you multiply 2 times 2 times 2, it's 8. You're not doing 2 times 3, you're doing 2 times itself 3 times. And then 3 times 3 times 3, 27. Same thing here, 64, and there we go. And again, you take it out as far as you need, but this is the magic perfect cubes. Get familiar with them, get comfortable with them, you're going to need them. Okay, now let's just start with the basics. They're nice when everything is, everything's just going to work out really well. These are all square roots. You can see you've got your radical, and there's not a number up there where the root goes. So you know by glancing at it, we're doing square roots. So we need that first list of numbers. Well, if you look at it, we've got square root of 25. We just did that. Square root of 25, now, I'll tell you what, remember that's 5 times 5, so we get 1 5 out. All right, now, I'm probably not going to show that step anymore, but I need to, let me add a problem here, because I just threw a variable at you. What if you had m to the 8th? So what you're doing, remember I said that you have to, and I'm going to make that smaller so it can fit. Let's do a 4. That's 4 m's, right? And what we said earlier was a square root says you have to have 2 factors underneath to get 1 out. Well, I've got 2 here and I've got 2 there. So that says I get 1 m out for this and I get 1 m out for that. So that's m and m, which is m squared. Now check out. I started with m to the 4th and I came out with m squared. What did you do to your exponents? Basically what you did is you divided. 4 divided by 2 is 2. So whatever, if you have an even power, this works out lovely. So even power, you're going to divide it by 2. That's what you are going to have once you take the square root. So the square root of 16, if you look at the list I gave you, square root of 16 is 4. And then you're going to take your power, you're going to divide it by 2. That's going to be a to the 1st. You're done. Okay. Now, I will say this. If you get to looking into some of the specifics, when you are taking the square roots of variables and you are doing an even root, technically that is the absolute value. And we would need absolute value. And it's only when you have the even roots. Okay. So we won't do that when we do cube roots. That's kind of like another discussion. Since we're going to have to keep this video short, I'm going to not discuss that here. But if you can remember that that's with even roots and not with odd ones, that kind of sums that up. Whenever you go through and do the next one, let's see here, the square root of 25, well, we've done that. That's 5. And then we have an exponent of 6. We're going to divide them by 2. That takes us down to 3. But we used a even root, put that in absolute value bars. All right, the square root of 100 is 10. Now all of these are going to be divided by the even root, so we're going to put them all in absolute value bars. A, B squared, C fifth. There you go. All right, now that's when everything works out beautifully. There were no quirks, no bumps along the way. Everything was great. And that was square roots. You can do the same thing for cube roots. Notice you just need to glance now, but do pay attention to what your root is. Cube root, remember 8 is 2 times 2 times 2, so this is going to work nicely, and look there, 3 divided by 3, that's going to work as well. You do not have to use your absolute value bars because you are dealing with an odd root. Okay, same thing over here. The cube root of 27 is 3, and we're going to say 9 divided by 3 is 3, and you're done with those. Again, everything was beautiful. But what happens when things do not work out beautifully? You've got to know how to reduce things and how to break down your radicals. So we got to look at what happens when you have just a constant and what happens when you have a variable. When you have a constant that's not in your list, you know, when we listed out perfect squares, 20 is not in the list. It went from 4 squared was 16, and it jumped straight to 5 squared was 25. 20 is not in that list. So what you need to do is think about the numbers that we listed, all the perfect squares. Is there one that divides into 20? And make sure you heard the word divides into 20, because we want to write 20 as a product. We need 2 factors, so 2 things that multiply to 20. So 4 times 5. Now I have a habit of always putting my perfect square up front and whatever's not perfect in the back. Because here's my logic. The first part, he's ready to move out. This part is going to be stuck on the inside, okay? So when you do the square root of 4, he ends up being a 2. He went out. You did the square root. So he gets out of the radical, but the 5 can't go. He's stuck. All right? So let me take this out just for the sake of discussion. What if you had 18? That's going to be 9 times 2. And remember, you're picking something out of your list of perfect squares. So if you don't know them, go back and look at your list. And you need to learn your list. So the square root of 9 is 3, and the 2 is stuck. You're done. All right, you are finished, and you know you're finished when the number that is left under the radical cannot be broken down anymore. So if you have a variable, and look, that's square root. 7 divided by 2, this is not going to work out well. But what you can do is you can break that up. So take your power, and you basically like pull your a to the 7th apart into 2 different products so that you have one very large part that has an even power, and then you got that one little extra over to the side. So basically all you're doing is taking that one extra that made a to the 7th odd and sitting him over to the side, and then you've got your a to the 6th, and yes, he's going to divide by 2. So this is ready to go out. So 6 divided by 2 is 3. He's on the outside, and this little a is stuck on underneath. Again, I should put that in absolute value bars. All right, then you're going to be able to put it all together. So again, it's square root. I have both. So make sure that you give yourself plenty of room. Don't squish yourself up, and work one thing at a time. Do your constants or your coefficients, and then do your variables. Don't try to do everything at once. Just work with the 12. 12's not in your list, but that is 4 times 3. But notice I left plenty of room to work with A's and plenty of room to work with B's. So just look at the A's. He has the 5th power. Well, that's not going to help me. I need to take him down a notch. So take one A off. That leaves me 4. Well, this is just 1B. I can't do anything with 1B. He's stuck. So none of the B's are going to come out. I don't have any B's on the going out pile. But once I get everybody sorted, so you do need the sorting line, then you can take all of this and you can do your square root. Square root of 4 is 2, and then your exponent you're going to divide. And then all of this back here, you're just copying him down. He's stuck. Now again, that's supposed to be an absolute value bars. All right, now this one's slightly different because we have a cube root. All right, so you have to think of your perfect cubes. Again, there's a bunch of coefficients and variables, so give yourself room to work. 16, that's going to be 8 times 2. All right, and then I need a number that is divisible by 3, but less than 7. So I could take 7 and I could move him down to 6, right? 6 is divisible by 3. So I need to step down to 6. If I did that, I need to put 6 of them over here, and there's one left over. Okay, then look at 11. I need a number, again, that's divisible by 3, but less than 11. 9 would work, so let's do 9 of them over here, but that leaves me 2 over there. So basically, these exponents have to add up to whatever's up here. Same thing here. 6 and 1 gives me 7. Okay, now you're ready to move. These should work beautifully. That's going to give me, 2, a to the, when we divide that out, that's going to be 2, b to the 3rd, and then all of this is going to be stuck. Okay? Hope that helps. Give it some practice. You can come see me if you've got any questions.